So the power of I. I told you I love this topic. Isn't it cool? So we know I squared is equal to minus 1. Find the first 9 terms in the sequence whose general term is I to the n and represents these on an Argand diagram. Recall that in the sequence we generally use n equals to 1, 2, 3, and 4. So what we have here, I've already actually put down I to the 1 to the power of I to the n. Now, this is going to be I. Hold on. Just need a pen. Okay, so we've got I here. I squared. Now this is I squared times by I. And then we have I squared times by I squared. So what we have here, well, this one remains as I. This one is minus 1. That's minus 1 times by I. And minus 1 times by minus 1. So we're left with I minus 1 minus I, 1. Now if we look here, we have I to the 4 times by I. Now we have I to the 4 times by I squared, I to the 4 times by I cubed, I to the 4 times by I to the 4. And we know from this one, I to the 4 is 1 times by I, 1 times by I squared, 1 times by I cubed, 1 times by 1. So that one's 1, this one's I. Now I squared is minus 1, so this one's minus 1. I cubed is minus I. And you'll see how this is actually repeating. So this one here is I to the 4, I to the 4, I, which is going to be 1 times by I, so I. So it's actually just repeating every 4. Okay? Now, if we plot this on the Argand diagram, what we have is I to the 1 is up here. So this is in fact I to the 5, I to the 9, and we can actually come up with an expression for this. We can have I to the 4m minus 3, where m is 1, 2, 3, 4, etc. Okay? Then if we multiply all these values by I again, we get I squared, I to the 6, I to the 10, etc. And these are all equal to minus 1, but that's the same as I to the 4m minus 2. So multiplying by I has taken us there. Then multiplying again, we get minus I. So this is actually I cubed, I to the 7, it's a 7, I 11. So we're looking at I to the 4m minus, well, I to the 4m. Minus 1. 1, yes, I to the 4m minus 1. Okay, so that means multiplying by I has rotated us another 90 degrees. And lastly, we have I to the 4, I to the 8, I to the 12, which goes to I to the 4m. So multiplying by I again has taken us another 90 degree turn. So essentially, multiplying by I rotates anti-clockwise, ACW is anti-clockwise, by 90 degrees, or pi over 2 radians. So if we want to simplify I to the 2011, what we want to do is see if we can actually get a multiple of 4. So I to the 2011 is the same as I to the 2008 times by I to the 3. So 2008 plus 3 is equal to 2011. So this, since it's in multiples of 4, is 1 times by I3, and I3 is 1 times by I squared times by I, so we're looking at minus 1. Complex numbers can be added and subtracted quite easily. It is just adding the real parts and the complex parts. So we have 3 plus 5 is equal to 8, and 2i plus 7i is equal to 9i, and subtracting 3 minus 5 is equal to minus 2, and 2i plus minus 7i is minus 5i. Now, a little bit more complicated is multiplication of complex numbers, because you must remember that I squared is equal to minus 1. So 3 times by 2 is 6. 3 times by 6i is 18i. And 2i times by 2 is 4i. And 2i times by 6i is 12i squared. So we can just add these two to give us 22, but we need to replace the I squared by minus 1. So it's 12 times by minus 1. So it's 6 minus 12 is minus 6 plus 12i. So let's do this in an example. 1 times by 2 is 2. 1 times by 5i is plus 5i. Minus 4 times by 2, so it's minus 8i. Minus 20i squared, and we're left with 2 minus 3i plus 20, so it's 22 minus 3i. So all you have to remember is that I squared is equal to minus 1. Now, what about a complex number times by its conjugate? So we've got 3 squared plus 15i minus 15i minus 5 squared I squared. These two go. 3 squared. Now, this is actually going to be plus 5 squared. So it's 9 plus 25, which is 35. So if we do this just with pronumerals, we've got a squared minus ABI plus ABI minus B squared I squared, which is A squared, that goes, plus B squared. So in general, if Z is equal to A plus IB, then Z times by its conjugate is A squared plus B squared, which is in fact the modulus squared. The reciprocal of a complex number is when we multiply the numerator and the denominator by the conjugate of the denominator, as in the example on the right. So here we have 3 plus 4i multiplied top and 1 over 3 plus 4i multiplied top and bottom by the conjugate of the bottom number. So 3 minus 4i on top and bottom. So if we expand it out, we get on the bottom 9 plus 16, or 25, and on the top 3 minus 4i, and we split this up, and this will actually give us that number in its Cartesian form. or rectangular form, where a and b plus bi, in the form a plus bi, where a and b are real. Okay? Now, this is similar to rationalize the denominator when working with surds. Now, we can use the reciprocal when we're dividing by a complex number. So if we have 1 plus 4i divided by 2 plus 5i, we end up having, let's multiply top and bottom by the conjugate of the bottom, 2 minus 5i. So this is going to be 2 minus 5i plus 8i minus 20i squared over 2 squared plus 5 squared. So we have, now this one's going to become positive. So we've got 22 plus 3i over 29. So in Cartesian form, 22 over 29, and you do need to split these up to get it into Cartesian or rectangular form. The same thing when we're simplifying other fractions. Now, this one should have actually been 1 over I. So if we multiply top and bottom by I, we get I over I squared, which is going to be I over minus 1. So it's minus I. And this one, 2i, 2i. So we've got 6i plus 14i squared over 4i squared. So it's actually minus 14 plus 6i over minus 4. Divide through by 2. And the negative, so it's 7 over 2 minus 3 over 2i.